Okay, I think we're going. So, all right. So, section 1.1 is about lines. Like we said, this is going to be a lot of review, but there's going to be a little bit of change in some of the vocabulary. And the first thing that we're going to talk about that is a little different, but it's something you've seen before, is called coordinate increments. And basically, coordinate increments refers to change in x and change in y, which is kind of the building blocks of how we would do slope later. Okay, and we're going to use the Greek letter delta. Have you guys all seen that before? Familiar with that? The little triangle means change in. Okay, so delta x is the change in x. So if we have two x coordinates, it would simply just be the difference of them, x2 minus x1. Okay, that's the coordinate increment of x. And then the coordinate increment of y, same thing, simply be the change in the two y coordinates that we would have. Okay, so as an example then, we're going to find the coordinate increments between -3, 1 and 4, -2. Okay, now, it kind of depends on which order you're going. So there's two sets of answers for this. So can somebody give me what they believe is the answer for delta x for this example? 7. Okay. Because if we go from -3 to 4, we got to go up 7, right? You can do it that way. Or you can think of it as 4 minus -3. If we just do the subtraction, that's also 7. Okay? So I'm going to write it out that way. Okay, now I said that's one answer. There's technically another one. If I had looked at it a little bit differently, what's another answer I could have come up with for delta x? -7, right. Depends on the direction you want to go with it. So, say, or delta x could have been, and if I subtracted those two numbers the other way, -3 minus 4, I get -7. Okay, and so delta x, or delta y rather. Okay, if I'm doing this same kind of thing, let's subtract in the same order that I did the delta x right above that one. What should be my coordinate increment for y there then? -3, right. -2 minus 1 is -3. So if I, again, flipped it around, the delta y would be then 1 minus -2, which would give you a +3. Okay? So usually they're going to say from this point to that point. Okay? So if we did it, another example here, and we did the same question, but let's go from 3, 5 to the point 4, 8. So that kind of indicates a specific order or direction that you're going with it. Okay? So from 3, 5 to 4, 8, what would be the coordinate increments then? What would be the delta x and the delta y? So 3, 5 is like your starting point. 4, 8 is your ending point. What do you think? be 1 and 3. Because this is kind of like your x2, and this is your y2, right? Because that's the second point you're working with. This is your x1 and your y1. So you'd be subtracting this minus this. So this would be 4 minus 3, which is 1. And the other one would be 8 minus 5, which would be 3. So with that indicated direction, it has to be that to make it work. All right. So let me scoot this up. All right. So creating equations. That's the other thing that we're going to be working on quite a bit here. So given some information, can you produce an equation? Okay, and we're going to talk about all the different forms of linear equations that you guys studied in the past as well. Okay, so start with the one that you already know well. Let's say we know the slope of the line has to be 3, and we would like to pass through the point -4, 5. Okay, so how would you guys attack that one? First of all, what form of an equation would you want to use for this? What form of a linear equation? Give you a hint. The first piece of information should kind of lead you there. Slope-intercept form. Yeah. So let's jot that down if we don't remember it right off the bat here. Y equals mx plus b. M is your slope, b is your y-intercept. So what can I do with this now that I know the information I have up top there? We can replace the m with a 3 at least. We can start with that. Passes through the point -4, 5. So how am I going to use that information? Yeah, we can plug that in for x and y, and that'll allow us then to figure out the b, to find the y-intercept. Okay, so bring it up over here now. So the y is 5. The x is -4. So 5 equals 3 times -4 plus b. Solve that for b. Let's see if I'm doing my math here right. I'm getting 17. Yeah. Does that sound right? So it'd be -12. You add the 12 to the 5, and you get 17. Okay, so my equation here then is y equals 3x plus 17. And that is in slope-intercept form. Okay, which is the first form you guys learned and probably did like 90% of the time when you were in Algebra 1, and even moving forward to some degree. So now I have this one in slope-intercept form. Let's see if we can convert it into another one of the forms you guys are going to use, and that's point-slope form. And I won't make you guys recite this one from memory, but I'm hoping at least this one looks somewhat familiar. Does it? Just a little bit, yeah. Y minus y1 equals m x minus x1. So in this one, this is another way we could do the same exact problem. If we have a slope and a point that we know that goes through, we can just plug all that information right into this one to start with. Okay, we don't have to go through the solving for a variable like we did the last one. Okay, both methods are fine. It's just a different way to do it. So with this one, we could plug in y minus 5 equals 3 times x minus or plus 4. And if you were to do the distributive property and add the 5 to the other side and all of that, you'd end up with the same equation we just had, right? Y equals 3x plus 17. It gets you to the same place. I might ask for slope-intercept form. I might ask for point-slope form. So this might be what I'm looking for in the problem. It just kind of depends. So I'm going to just highlight it as the point-slope form of the answer as well.